All right, for those that are online, are you able to hear me okay and also see the screen with this new problem as 6.26? Okay, great. Thanks, Carly. All right, so we're going to work on this problem. So 6.26, you're going to determine IC of t. So those that are online, go ahead and work on it. You can work on it individually, or if you guys are willing to chat, you can go through chat, or you can actually vocalize. All right, you guys here, go ahead and break up into your small groups and work on this a second, and then start to talk to your peers and see how it is going.
Okay. So I was looking back through the picture. So after your 0 and 0 plus, and so your initial voltage for the capacitor continues to vary, and then it creates a current through the resistor, and that's your IC of 0, which is 2 amps. If that makes sense.
Yes, but I agree. Did you get it? We decided series of powers on the
I just have a quick question.
Yep.
I'm still a little confused on when or if we're supposed to solve for VC and IC when 0 approaches to the right. Like I know the right form, like it's in this form here,
Mhm.
but I'm like confused on when
So-
we have to do this though.
So you still want to draw in, like, there's still the 24 volts and the 2 ohms. To make sure you keep the sources in there too. Yeah. And so from here, this will be the circuit that you get the initial value of IC. So IC will be the current going through this,
Okay.
through this branch. And then this is going to be open. Because right after the switch, it's
Oh,
open, so
right.
that's not connected. And so IC is the current here, which will be what?
It'll be equal to the current going through IL.
Uh-huh. And then IL is found from this circuit. So this is why it's a little confusing, is the initial time is actually after the switch opens. But in order to know what these values are, you have to solve this circuit first.
Okay, right.
So in this circuit, you got 16, and then IL will be what?
In here, you'd get 8 over 4 amps.
Yeah, I did get omega naught. I got root 6.
Let's see, 24 over 6.
Oh, over 6. Then
I see. I'm getting weird answers because this.
So
calculator that I
this will
have
be the
today
current you're solving for in this circuit.
okay, right in this circuit.
Uh-huh.
So
Yeah. Bigger bite.
in that case, that would be
So you can either do, like, the current here is this voltage minus this voltage over 2 ohms. Do you see that?
right. So the 24 minus 16, 8 over 2.
Uh-huh.
Oh wait, no, yeah, that is 4 amps.
Uh-huh.
Okay.
But I just wanted to make sure you're getting it from that circuit.
Yeah. I was. Well, I
Okay.
was then. Because I just did the 24 here minus the 16 here. But
Oh, okay.
I get how you're
Yeah.
supposed to do it. So, and then that's still different from the final state that's drawn as a short and then as an open here, right?
Mm-hmm, correct. Yeah.
So the only difference between these two is the values we find from the capacitor and the
Inductor.
inductor's current.
Uh-huh.
Okay.
Yep. And then this one will be your final value.
And then,
So you have this is initial value and then final value.
so are these not both your initial values?
So this is really your initial value, but when you draw this in, you're like, I don't know these values.
Okay.
So because you don't know those, you have to take a step back and find them before the switch
Okay.
moves.
So this technically is the initial,
Correct.
but then sometimes we have to go back to this.
Correct.
And then sometimes even these two are the same.
Correct.
Okay.
Yep.
Okay.
For our initial current, is it, so no current will flow through there because it's the open, so the initial current will be the voltage over these two resistors added.
Does that mean that they're critically damaged? Pretty much.
So I think this is 24, so that's 24 over 6.
So it should be 8.
24 over 6 is 4.
I'm bad at math.
There you go.
Okay, and then how do you go about finding the final voltage? Would it just be voltage times?
No, it's just that,
It's just the voltage?
right, because it's open.
Okay.
So there's no current flow, so it'll just be measuring across that
Okay.
battery.
So it's 4 over 24 plus the square root of 4 over 24. over and then under 1. So you have to do that as well. Because you got.
Oh yeah, you're right. No, but then this shows that they're critically damaged.
You have to put it over 1. They're not. If it's within 0.05, are they critically damaged?
It's not within 0.05 though. It's within 0.001.
I agree. What do we do?
It's definitely critically damaged.
Is 0.05?
Dude, look.
Point.
Your
Alright, let's go
calculator
over
is
that.
definitely grounding for
It is
you.
0.05.
Yeah, I rounded.
This is
Point
your
zero five.
Look, you can do 0.25.
I see 0 or your BC is 0.
0.05.
And so you have to solve for this. And
I mean, I still feel like that's 100. That's a 500
Isn't that like
of critically damaged.
exactly the statistical significance?
Okay.
Yeah.
Oh.
I just want to see if I thought about this right.
Yeah.
For VC initial, I just did
I'm
note
gonna. I
voltage.
feel like it's critically damaged.
VC minus 24 over 2, VC
Yep.
over 4, which
Yep,
gave me
16.
16.
Uh-huh.
Yeah.
Yep,
Because
you
of a
did that right.
0.05 difference.
Yes. Is it overdamped? That's right.
Okay, so let's, series or parallel. So first step is series or parallel, and it is series. Oh, that is big. So good job finding it in series. So it is series. So first step. Second step is to determine what?
Second step. Alpha and omega. Like alpha.
Alpha and omega not. So if it's in series, alpha will be RTH over 2L. And so we have to look at RTH from a final spot. So the final circuit will look like what is going on with the switch in the final circuit? Open, correct. And then inductor will be
Maybe a short
wire, correct. And then this will be an open. And then what do we do with the voltage source for RTH?
We treat it as a short.
Correct. So short it. And then our pathway, this will be ignored. And then our pathway will be between A and B. So RTH is just 2 ohms. So 2 over 2L, and L is 0.4. So we get 2.5 units, meters per second. Good job. And then omega naught is 1 over the square root of 0.4 and 10 over 24. And that is 2.4495. And units for that?
radians per second.
Correct. Radians per second. So, you were saying how close is close enough? And so, because these are, so that is a good question. Like, how do we say how close these are? So if this was like 2.49,
Then we might.
then I would probably say, that is really close. With this still like 2.45,
That's enough of a difference.
that's enough of a difference. So 0.05
Is enough to be critically, or to take it from critically to overdamped.
to overdamped, correct.
So on a test, if there's like, if it's 0.03, can we just choose one? Or do we get marked off for that?
I'll try to not make them that close. I'll try to make it a little bit more obvious. But say you are like in real life, like, okay, I'm analyzing this. What are these going to look like in the graphs? In the end, if you pick, and they're that close in value, they're actually going to look graphically pretty similar. So whether you do overdamped or critically damped, they're not going to look that different once you actually graph them. So in the end, does it really matter? Yeah, not really.
As they approach the same value, then it's gonna look the same no matter what. So
Correct.
Choose whichever you prefer.
Yeah. So in exams, I'll try to make it a little bit more different, so that would be more obvious. But if it was that close in an exam, I would probably have the grader go back and say, like, if they're that close, you could let them choose either one. Okay, so it is overdamped, so make sure you're solving this as an overdamped system.
So, I also have another question about the whole money because I'm so lost on it. Okay. I feel like I'm so close to solving it all. So, initial, we find these initial states and IC of 0 minus is 0, but IC of 0 plus is IL of 0 minus. And then I pretty much just use what I need from here and then graph the finals and put it in the equation.
Yeah, so,
Yeah.
so yeah, so you need S1, S2,
Right.
and then
Mhm.
AC0, BC0, BC.
Okay. Should I ask you about the is this one is I'm losing
So
my
at 0
mind.
plus,
I'm
right?
losing- This is
Your inductor is
so
gonna turn into
I feel like my work isn't that
and
good.
the capacitor's gonna turn into a battery.
So it's here and then it goes to there.
Yeah, so at either the initial, at both the initial and final, we see a
So
T
I'll get
is
fully
gonna be
charged
0.
and now.
Because before, it doesn't have any sources charging it. The second it flips, it'll have that current going through it, but it'll discharge, so at 0 and infinity, they're both zeros. So then I got some crazy work here. I got an alpha that was way bigger than my omega.
Yeah, I'm not sure why.
So I did overdamped, did this guy, and this was my answer that I came to, which doesn't make sense to me.
So, go back to overdamp.
Like, I've gone over this so many times, and the only way I'm making like a mistake is if I'm evaluating the states wrong. What? IC of 0, IC of 0 minus or plus, because current around the capacitor can change instantly. So the second it flips, IL of 0 minus is going to be IC 0 plus.
So this is hard to see, but, because you have a 0 and then your initial is 0, but then you go back to 0, what it's doing, this is, I was looking this one to see it better, but it kind of goes up or goes down and then back to 0, which is what it's doing.
But, okay, so then this is the right form.
Yeah, so, yeah, but your end will go back to 0.
Okay.
So there is a little, like, there's a sinusoidal look at
Okay, I figured that, cause I like knew it would have to go up and then go down after it starts to turn. But I just feel like if I enter this into the, form,
It's gonna be a
format,
small
it's,
amount.
Yeah, so
Small
if your
amount.
inductor's right here.
I mean, 'cause it's
to
gonna
find the
just
current for
kinda-
that, you just do
Mhm.
voltage times by, yeah,
Yeah.
or divided by.
isn't that, this, like, there's nothing else I can do.
It's just so weird, I'm like, I just cannot believe it.
There's no way she got
Solar
it.
resistance.
Like 5533.
Yeah, I did it, which is what you did there. Right.
Okay, I mean, if I calculated it right, it's right.
Yeah, as long as the other values are, but
Yeah.
that would just be not.
Okay. I will try to.
Oh, yeah, that
explains
explains
why
why.
I went wrong there.
10,000 volts.
Okay.
1,000 volts?
It's like the numbers.
I have a zero minus.
Last time it was like 300 something volts before, it was like, there's no way.
Did you do PS divided by
I s-
R1 plus R2?
I never went above 100 volts at any point in my equations. I have no idea where you're going.
But I got it right.
We got different problems.
Yeah, that's the thing, all the numbers are different. What?
You do R1 plus R2.
Yeah, and they're weird as hell.
So it's
Cause they're in
Yes.
series.
And so you have to
Okay.
draw,
So then
you
yes,
have
minus
to redraw,
I got it. So
Twenty-four over
the
six.
inductor will go
Yeah,
to
which is four.
a current source. And then this is gonna be, this is
Oh.
four.
We're gonna get used to that.
That always stresses me
Okay,
out.
yeah, so 3 volts.
Cross
is-
switch. Well,
And then
that's what's.
this will be zero, right?
It has to be cross switch.
Because initially it's on the
Right.
So that will be zero current.
Okay, got you, got you.
Does that make sense?
You found the other one and then put it minus. Okay, so all we need to do is
That will be zero.
Dude, these problems are
So then. Oh my god.
I kind of go to this general side distinguish.
I seriously gotta print that out and write it down.
I know, dude.
Bad.
So if you did
That
that
was a
table,
fun-
oh,
Yeah.
I wrote it down yesterday in class, or the other day in class.
That
To take-
there.
yeah, writing that down
I
is-
need to do that.
So we got 4 over 6.
Oh, so I got it. I got these zeros.
Oh, I need to find A1, dude, this stuff is so easy.
So I see 0.
So then 24 minus 16 would be 8, right? By 4 would be 4.
I know you know. 0.4, I see 0.
A1?
Uh,
I've gotten A1 to be
VC of 0.
negative 14.
VC of 0 is what?
Are you sure you remember to divide by S one minus S two?
VC of 0
Yeah,
plus.
that calculates out
VC
one.
of 0 minus, or no?
Wait, DC of 0 plus?
Yeah,
Same as
S1 is
VC of
negative
0
2, S2 is negative 3.
Yes.
Okay.
Whoa, not quite.
9.6
What do you mean, not quite?
minus.
So that's what's negative.
Yeah.
You get 16 from that. Yep, I see what
Huh?
happened.
Oh, I did a
See what
voltage
happens.
divider. So I did 24 times 4 over, both resistors.
I checked by graphing the equations that got me at starting with the values were not right, so I'm gonna go with this. No, it's not that I'm doubting you, it's that I'm trying to reaffirm myself, because now I'm nervous.
Infinity
Is it negative one?
For A1?
Negative. What'd you guess?
14.41.
Yeah. Yep.
Well,
Once I realized that I
So
was
it's gonna be
kind
an
of
O. It's just gonna be yes.
Minus 0. No current over 4 is equal to 0. Then if you multiply this by 2.
For a second, I was having trouble figuring it out.
The final IC,
Add those.
but then I remembered I had about 12 by the capacitance.
Add 2,
I would do
4
it,
times
but
0 is 0.
I should.
And it's VC
Be okay.
minus 48 and negative 48. And VC is 16. Oh, so it must be 12. Oh, times 4, 48.
What'd you get for A1?
I haven't.
Did you get negative 6?
That one I took off. Yeah.
Positive 6 point, so on and so forth.
Okay, yeah, this
I
will be
know.
negative, so then
Yeah.
this is the you're gonna make that divide by negative, it's gonna be positive. Yeah.
Oh, those were terrible.
Dude, that's the.
What did you guys get for S2?
Yeah.
Okay.
And S1, I don't wanna like.
S2 I got negative 3, but it's around.
And then A2 should come out as 6.
Do I need to round it, or do I need to like
I was
keep
on
it?
2.
That's fine. And then S1 was what?
Yeah, it was negative 2 actually.
Plus 3 VC of 0. What's VC of 0 again? I didn't do it. How am I calculating?
And then when you redraw it.
S1 is
plus
a S2.
So wait, S1 or S2 is what?
S2 is negative 2.
S2 is negative 2.
Well, this would be.
No,
zero.
S1 is negative 2, S2 is negative 1.
Okay. Your VC of 0 is like 16 or something?
I know. That's terrible.
So for A1, I got 10 minus 24.
It's just when you originally draw this, it's like, you don't know what these two values are. So
Negative 14. I don't think that's right. IC of 0 is 4.
I see of 0 minus.
What? No, IC of 0. IC of 0 is IC of 0 plus. So, IL.
Okay, well, IL, right?
Yes. Yeah, so
Okay. Is it 12?
right here, before it switches, IC
Is 0.
is, yeah, it doesn't have one. But
Yeah.
L has something, you know? L has a charge. Second, it's flipped. All of IC can now be like, oh wait.
Is it already fully charged?
Wait a minute, yeah.
Whoa. For one, okay. So, remember close to, but, other than that.
And it's not even discharged.
Okay.
I just have to
Discharge.
No, so IC of 0 minus is 0. And then you flip the switch and yeah, but now no, it's discharging.
No.
Minus 2 minus 3, correct?
No, it's yeah, it charges more. It charges more. Yeah. Because now it doesn't have to send current through the R2, so it charges more. It
At 16 volts.
yeah, so we're right still. It is IC of 0 plus is IL. Because right, so
I got
So I just tacked it on the end.
I got 4.
okay, yeah,
Is
that's
that
right.
what you got?
Yeah.
Okay.
So that's why I did 4 divided by 0.4, which I got 10 for.
I did not get that. Wait, I got
4 divided by 0.4 is 10.
That's what you're supposed to do.
Wait, you're supposed to.
Nothing you're supposed to do from that.
Well, IC of 0 is 4,
So,
and you times that by 1 over 1, which is 1 over 0.4. You see 0.4.
No, that's L. C is 10 over 24. That's why. Okay.
So you're electrical engineering, of course it's so good on it.
Okay.
Yeah.
I realized that last semester.
And so I got 2 plus 2. I got 8 to H.
I was like, there's no way.
I solved for this is the F for it.
It's the funnel.
all right, so initial has become a question on a lot of people. So to find the initial circuit is actually when the switch has already switched. So in this case, it would be open. And then this is acting as a current source, and this is acting as a voltage source.
Wait, why is the initial the switch hasn't flipped yet? Oh, 0 plus.
0 plus. So this is where you're actually finding the initial value. But here you don't know what these two values are, right? You can't just look at the circuit and say, oh, that value is this. So that's why you do the time right before, which is when the switch is still closed, and then this has been sitting there for a long time, and so this is a short and this is an open. Does that make more sense?
Mm-hmm.
Okay. So that is what you're using this one for, is to find VC and IL for sources at initial time. Because we're actually finding t greater than or an equal to 0, but right at 0, it's like, well, what does that mean? And it's always like right after it on. Yes?
How do we know like when we need to find the t equals 0 minus and t equals 0 plus? Because like when we were just doing like RC or RL, we would just do like one initial.
And that's because it was the same for both.
Okay.
So always draw this initial at t equals 0 plus, and then look at that and say, well, do I know the source and do I know this? If you know enough information, you can just grab those initial values. But most of the time you have to go back and get that initial value. So in this case, to find those two values, VC is going to be the voltage across, oops, So this is all the same wire. And then if I put my ground here, then VC is going to be found by VC minus 24 over 2 plus VC over 4. And then I can solve that to give me VC is 16 volts. And so that will be used here for the 16 volts. IL will be the current, and I only have one branch, but knowing VC, I can say that IL is 24 minus 16 over 2, which is 4 amps, or I can look at there's only one branch there and say 24 over 6, which is also 4 amps. So either way to get that, this will be then the initial value for the current. And then the initial values we need is VC, which will be 16 volts, and IC, which will be 4 amps. And these are going to be your initial values. All right, any questions about that? Does that make more sense with the initial time? Okay. All right, so from here, this was our second step, was to find the initial values. The third step is to find the other variables. So we can find, we need A1, A2, VC infinity, and S1 and S2. So we start with final. So final for VC infinity, again, this is open, this one is open, and this is a short. And so VC will just be 24 volts because there's no current flow here. With no current flow, this all looks like the same wire. Okay, so VC infinity will be 24 volts. And then I have these written down so they're much easier to read. I'm going to copy the written down ones. Well, actually I didn't write them down. I'll just copy this one. All right, so A1 you should have found, or S1 is minus 2 and S2 is minus 3. A1 ends up being minus 14.4 and A2 ends up being 6.4. And so you put that into the VC equation, and then you take the derivative of that to get IC and multiply that by C. Yes?
What did you get? -2 and -3 for S1 is 2. I got -2.23 for S1.
It's 24 over 10 because it's 1
for
over
S2.
C.
Or for S2.
That's,
He's right.
Did you guys also get those?
We were so close to being
Huh.
I was almost done. We were almost done.
Although I didn't round as much, but it's still pretty close.
yeah.
Did you round them?
No.
So you used,
No, I got your answers. You're totally on track.
so used alpha was, I'm gonna put alpha back down here. So used alpha as 2.5 and omega naught as 2.4495.
Wait, no, I got. Wait. I'm confused.
What did you get?
What did you get for
Okay,
A1?
if you do
What did you get for A2?
A1,
Multiply the capacitor value.
negative 14.4.
Cause I got like
Section?
28.8.
No, I did round it to 2.5.
Yeah, so 28.8 and then multiply it by 10 over 24 gives you 12.
Oh, it does? Okay.
Yeah. And then, yeah, so that's where the 12 came from, was multiplying by C of 10 over 24.
The next numbers appear in the last step.
Yes.
10 over
Yeah.
24.
Because I got the same.
So,
I got the same.
did you use,
I used 2.4. Did you flip something else?
okay, so you see where the difference is then? Okay. As I was gonna say, it should be pretty close to those. Okay. Other, other questions, comments? Yes?
Trouble like conceptualizing like O plus like the initial one's open.
Yeah, which is
There's two battery sources. Like how the current is like flowing through the 16 battery source, I guess. Way down.
Like here?
Yeah.
So what part of that is,
Like I'm just like how you like conceptualizing how like two battery sources, 24 and 16.
You're doing like 18.
Current flow through that battery. Like I guess I don't understand what batteries do.
so, yeah, so in this case, right as it switches, it's changing constantly. So it's like right at this point is 16 volts, but then it changes to some other value right away. So it's going to start to charge up to 24 volts. So it starts at 16 and then kind of charges up to 24 volts. Yeah. Does that help? Okay. So the final, find the graph of this. So this is what the final graph looks like.
I lost my Apple Pencil. -14. Yeah, but you didn't divide it by S1 and S2. S1 minus S2.
Paste. All right, so the current IC, it goes up to 4, and then it discharges down to 0. For that capacitor voltage, like you were asking about, it starts out at 16, and then it charges up to 24. And then it's an open, but it's set, it doesn't go any higher than the 24. So that's the graph of what it looks like for the VC, and the IL starts at 4 amps and then discharges to 0. So it looks like those graphs.
For a midterm,
Uh-huh.
do you ever have to provide the graphs?
No, I won't make you graph them. Nope, I will not make you graph those. But conceptually wise, I kind of want you to understand, like, how does this look? You know, so this is kind of what that exponential graph looks like. You know, and if you get critically damped, it's going to just go a little bit sooner, and then under damped, you get some oscillation. You can get more oscillations in there. Okay, so that's kind of conceptually what I want you to understand from the graphs, but I won't make you actually graph them. Or if I did, I'd say use MATLAB. But I won't make you do those. Okay, other questions? So for the midterm coming up, which is what maybe you were asking more about, RC circuit solution, RL circuit solution, RLC. So far we've done mostly this overdamped. So we're going to continue to do critically damped and underdamped, and hopefully you'll get very comfortable with each of those different types of characteristics that you can have. Concept questions we'll be asking more like, if you look at this, what does it look like? Is this a overdamped, underdamped, critically damped graph? So that would be what I would ask as more of a concept question than please graph this. Okay. So understanding concepts of what do these mean.
The graphs would be a little easier to figure out if they're critically damped or
This, correct. Like I couldn't look at this and say this is critically damped or this is, you know, it's not as obvious to me as something that would look more like, let's see, let me go back to, You know, here it's like, yes, that is more obvious, like, oh yeah, there's ringing, it's definitely underdamped when there's oscillations in there. Critically damped and overdamped get to be a little bit harder to see the difference graphically, because you can see that looks pretty close. The overdamped, the only thing you notice is it's like way under what I would kind of expect like a real exponential to look like, where it has a lot more curve to it. So if I asked a question like that, I would definitely make it more clear. Okay. Because it would be hard, you know, and I couldn't, like, if I gave you something that, like, is this critically damped or overdamped? It's like, well, they look very similar. So I would have to put like an ideal case and then where the actual one was. And from there you could say like, oh, if that's ideal, then that's probably critically damped if it's really close to it, or overdamped if it's way off of it and not quite meeting it, if that makes sense. Okay. All right, any other questions? Okay, we'll do more problems and examples on Friday. I gotta think, what is this date? Oh, a heads up, on Monday, we will not be having in-person class again. I will be out of town, and so I'm gonna post again next Monday. Okay, so we will not have in-person class. So I'm gonna post again solutions for, I'll probably try and do a solution for each type of problem, so the 3 problems. And so you guys can work on those. If you work on the problem and you get the solution, great, don't need to go through the video solution, but if not, the video solutions will be there to walk through with you, okay? So that will be next Monday's lecture. Exam is on the 7th, I think it's the 7th of February? It's, yeah, Wednesday, February 7th. So it'll be a week from next, or 2 weeks from now. Uh-huh.
So I have a question.
Yes. Oh, sorry, just one second.
Okay.
Danielle, cannot change institution. So correct as far as the inductor would be, IL would be the same, but it won't be the same for the IC current, just the voltage across the capacitor. Hopefully that answered your question. Thanks.
Yeah, I have no idea. I got
Sorry, just one sec. Controls.